Okay, welcome to the video for day 3. Today we're going to talk about more exploring factors and zeros of quadratic equations, basically just more information to help us get ready to graph quadratics. So we have given the two graphs below, write a possible equation for each in standard form. Okay, so to do these, all I can see from the graph is the roots right now. Like I know that I can find the roots, but I need to find the formula. So we're going to do this idea of using our roots. So I can see here it crosses at 3 and at 5. So those are my roots. Those are like the answers. So remember how we talked about this in the previous lesson. We used our roots to then work backwards and figure out, well, what would those factors that those roots came from be? So we're going to do that same idea where I have, okay, the x equals 3. Normally we have a t-chart. We set it up between the factors, and then that'll give us what the answers are. Now we have the answers, and we're trying to work backwards to figure out, well, what would those factors have been? So instead of being the x equals 3, I want it to be the x by itself. So above this, I'm going to subtract the 3. I'm kind of working backwards. That's why I'm going upward so that it kind of looks like the factor would have. So we can see here I subtracted the 3 from both to get back to the x minus 3. So the factor that would have originally came from would be x minus 3. So then the same thing on the other side, subtract the 5, that will give us the x minus 5. And then that would be the factor that that one came from. So we can think of it all that way. That gives us the two factors. Now, I'm not done yet because they told me I needed to write this in standard form. This is an equation that's in the factored form. And now I'm going to do an area model because it's a binomial times a binomial to figure out what this is in standard form, meaning highest exponent to lowest and combining all of my like terms. So then I put them in the sides of the box method and then we'll fill in the area model. So x times x would give me x squared. X times negative 3 would be negative 3x, and then x times negative 5 would be the negative 5x, and then negative 5 times negative 3 would be 15. And then we can see on this on the diagonal, I do have like terms. The negative 3x and the negative 5x can be combined. So I wrote over here f of x equals x squared. Negative 5 minus 3 is negative 8, so negative 8x, and then I have the positive 15. So this is my equation in standard form now, and that is my answer. So the difference there was we needed to put it in standard form. You're going to try the next one, and again, this is my hint to you. Start with the roots, turn it into the factors, then double distribute to find your solution. The remaining questions on this page are all following the same idea. Find the zeros, find the factors, and then determine if the a would be positive or negative and explain for this parabola. The rest are all about taking, this one is a quadratic. We need to find the zeros, so that would be setting it equal to 0, and you can factor. You could use the quadratic formula also if you'd like. So that one is the only one that's a little different. 4 and 5 are both, we have roots, and we're looking to work backwards to find the factors. Number 7 you can skip because that one uses completing the square. So we can skip number 7. You can cross that one out. For number 8 here, we have a polynomial function graph to the right. You want to state the domain. Remember, my hint to you here is domain are your x values, range are your y values, find f of 0. So this is asking you to find a y value. So think of what that means and then explain what the name of that point is. This one asks for what intervals is the function decreasing. So we want to look and see at what point is the function going down. And remember, when you ask for intervals for when something is happening, those are x values. So you're going to want to use x values to represent this and x values to represent the interval for when it is increasing. The end behavior just means as we take the x values and go towards infinity, so this direction, they want you to say the same thing for the y. So as the x's go towards infinity, what value do the y's go towards? And the same idea here, as x's go towards negative infinity, what do the y's go to? Find the zeros of this function. Remember, that's just another word for roots, zeros, x-intercepts. So all of those mean the same thing. So zeros, x-intercepts. So go look at the graph and find where it crosses the x-axis. In H, it says which equation represents the graph and explain your reasoning. There's a couple of different ways that you can do that one. But those go back similar to how we have these roots ideas, and we're trying to use the roots to find the factor. Okay, we'll go through this more in class. I just wanted to give you a hint on them all so that you'll be ready to start once we get to class, and then we'll go through more together. Have a great night.